Is the vacuum really empty? Allow me to take you on a journey that will challenge every fiber of your intuition and put into question the very foundations of what you have believed reality to be. Because if there is one thing quantum observation has taught us, it is that the universe is a master of disguise, and its most astonishing trick, the one capable of redefining our existence, hides precisely where we least expect it, in apparent nothingness. From childhood, we were taught that the space between stars, the gap in a jar, the interior of an atom, is simply empty. An absence, a blank canvas waiting to be filled. But what if I told you that this perception is one of the greatest cosmic illusions? What if what we call empty space is actually a vibrant ocean, a boiling sea of energy, a field of frenzied activity that pulses with the invisible heartbeat of existence itself? Imagine a space that seems silent and dark, that appears to contain absolutely nothing, yet in its depths harbors the most fundamental, mysterious force of the universe. Classical physics, the one that gave us Newton's laws and the mechanics of machines, painted a predictable, deterministic universe where every cause has an effect, and empty space is merely the inert backdrop for the grand cosmic show. But the advent of quantum mechanics shattered that vision. This new science, born from exploring the infinitely small building blocks of reality, revealed a cosmos where nothing is as simple as it seems. It showed a universe where particles can exist in multiple places at once, where mere observation alters reality, and where the vacuum is paradoxically a hotbed of activity. Think of the atom. Traditionally, we visualize it with a dense nucleus at the center and electrons orbiting around it, separated by vast empty spaces. But quantum reality is far stranger and more wonderful. Those empty spaces are not inert. They are filled with what physicists call quantum fluctuations. This means that even in the deepest darkness and silence of interstellar space, where there are no stars, galaxies, or even a single speck of dust, energy does not sit still. It manifests as a ceaseless dance of particles appearing and disappearing in the blink of an eye, like bubbles in an invisible ocean. This concept, the quantum vacuum, is one of the most revolutionary and yet least understood in modern science. We are not talking about a literal void, a total absence of matter or energy. We are talking about a state of minimal energy for a quantum field, a point of equilibrium where the inherent uncertainty of quantum mechanics manifests in the constant creation and annihilation of virtual particles. These particles, though ephemeral, have real effects. They cannot be directly detected with current instruments, but their existence has been confirmed indirectly through phenomena such as the famous Casimir effect, which we will discuss in more detail later. Consider this. If you could observe the vacuum at a sufficiently small scale, you would not see the silence you expect, but a constant hum, a quantum fog where pairs of particles and antiparticles are born from nothing, travel infinitesimal distances, and then annihilate each other, returning energy to the field from which they emerged. It is like an endless cosmic blink, a vibrating pulse that never ceases. This incessant cycle of creation and annihilation gives the vacuum its incredible dynamism and immense, though hidden, energy. It is a constant energetic ballet, a silent but powerful dance underlying all the reality we experience. Understanding the vacuum goes far beyond mere scientific curiosity. If the vacuum is not an absence, but a source of energy and potential, what implications does this have for our understanding of the universe? If what we perceive as nothingness is actually a vast energy reservoir, could it be the hidden engine of existence, the source from which everything emerges? This poetic and scientifically grounded vision invites us to reevaluate not only the nature of the cosmos, but also our own place within it. It suggests that we are part of a far more interconnected and dynamic system than we ever imagined, where even the empty space between our cells between our thoughts is filled with the same fundamental energy. The question we must now ask, the one that will guide us through the next chapters, is, if the vacuum is this ocean of energy, how does it interact with the matter we know? Could it be the source from which the particles that make up galaxies, stars, planets, and ourselves emerge? Could it be the true cosmic womb, the mother of all existence? The answers to these questions are not only fascinating, they are, from a scientific perspective, a gateway to a new understanding of reality, an awakening that could transform your view of the universe and yourself forever. We have begun to glimpse the true face of the vacuum, a face not of absence, but of limitless potential, a face that, as we will see, hides the deepest secrets of creation and existence. We have begun to realize that the vacuum is not mere emptiness, but an immense ocean of fluctuating energy. But how can we be sure of such a counterintuitive claim? Is there tangible evidence, irrefutable proof that nothingness is in fact teeming with activity? Allow me to guide you to one of the strangest and yet most beautiful phenomena of quantum physics. A stunning demonstration that the vacuum is not only real, but has the power to exert force. The Casimir effect. Imagine a seemingly empty space. Now, place two parallel metal plates very close to each other within that vacuum. What would you expect? Logically, nothing. There is no air, no interacting particles, no obvious forces pushing or pulling. Yet in 1948, Dutch physicist Hendrik Casimir predicted something extraordinary. These two plates in a perfect vacuum would attract each other with immeasurable force. The surprise was immense. How could nothing generate a force? Casimir's explanation lies in the quantum nature of the vacuum. As explored earlier, the quantum vacuum is not still. It is full of virtual particles, constantly appearing and disappearing. Think of this vacuum as a boiling sea, where countless energy waves of all possible wavelengths form and dissipate every instant. These are vacuum fluctuations, the invisible pulse of the cosmos. Now, what happens when we introduce the two metal plates? They act as a kind of boundary, a quantum cage. The vacuum energy waves outside the plates can have any possible wavelength. However, the waves between the plates are limited. Only waves whose wavelengths fit perfectly between the two plates, like the vibrations of a guitar string of a specific length, can exist in that confined space. It is as if only certain quantum notes can resonate within that cavity. The result of this limitation is fascinating. There are fewer types of virtual waves possible between the plates than outside them. This means that the pressure exerted by virtual particles on the outer faces of the plates is slightly greater than the pressure from inside. This small difference in pressure, this subtle asymmetry created by restricting vacuum fluctuations, manifests as an attractive force between the plates. It is a tiny force, yes, but it is real. A force that pushes the plates toward each other. Direct proof that the vacuum is not inert, but a dynamic ocean of energy. It is as if the plates are two boats on a turbulent sea, with larger and more numerous waves outside pushing them together. The Casimir effect is a stunning confirmation of the inherent activity of the quantum vacuum, a proof that even in apparent nothingness, powerful and measurable phenomena exist. The experimental confirmation of this prediction did not come until 1958, with Marcus Sparnay's first measurements, though with large margins of error. Later, in 1997, Steve Lamoureux's experiments measured the Casimir effect with astounding precision, nearly perfectly matching Casimir's theoretical predictions. This was a decisive moment for physics, a clear validation of the vacuum's vibrant, active nature. This discovery is much more than a laboratory curiosity. It forces us to reconsider our fundamental definition of reality. If the vacuum can generate a force, then it is not simply empty space, but a physical entity with intrinsic properties and an immense capacity to influence the universe. It shows us that empty space is full of latent energy, the origin of everything we perceive. Consider the implications. If the vacuum is the source of this subtle force, what other forces and phenomena might emerge from its depths? If the fabric of space-time, even in its most inert state, is a hotbed of creation and annihilation of virtual particles, could the vacuum be the true engine of the universe? The beating heart of existence? The Casimir effect not only validates the existence of virtual particles, but elevates the vacuum from mere backdrop to a main actor in the grand cosmic drama. This phenomenon connects us to the idea that reality is not static, but a constant flow, a dynamic manifestation of underlying energy. The vacuum is not a passive receiver, but an active creator, a place where the laws of physics materialize into observable phenomena. It is a subtle but powerful dance that invites us to look beyond the obvious, to understand that reality is far deeper, stranger, and more astonishing than our senses allow us to perceive at first glance. The Casimir effect is the window to that hidden reality, a reminder that even in what we believe is absence, there is undeniable presence. It means that we are not just the result of a random explosion, but the manifestation of a potential inherent to the very fabric of reality. Every atom in our body, every star in the sky, every thought in our mind has its roots in the invisible, fluctuations of this vast sea of energy. The vacuum thus becomes not only the origin but the mother of everything that exists, the inexhaustible source from which matter and energy continue to emerge. Even today, this poetic yet rigorously scientific vision of the origin of the universe invites us to profound humility and awe. It shows us that nothingness is, in truth, the starting point of the boundless complexity of the cosmos. It is not just the place we come from, it remains the matrix from which novelty emerges in the universe. It is the silent engine of existence, a reminder that life and matter are not anomalies but natural manifestations of the infinite possibilities residing at the heart of the quantum vacuum. We have seen how the apparent emptiness of the vacuum is, in reality, an infinite well of energy that could have given rise to everything we know. The next step in our journey will be to explore one of the most mysterious forces in the universe. One that forces us to consider how the vacuum continues to shape the destiny of the cosmos, dark energy. But the story of the vacuum does not end with the Big Bang. In fact, it continues to be written at every moment, driving the fate of the cosmos in ways as profound as they are mysterious. I invite you now to confront one of the greatest enigmas of modern cosmology, dark energy. What if this invisible force, this phantom pressure accelerating the expansion of the universe, were a direct manifestation of the energy inherent to that very quantum vacuum? For decades, scientists believed that the universe's expansion, initiated by the Big Bang, would be slowing down. Gravity, exerted by all the matter in the cosmos, was expected to act as a brake, causing the expansion to gradually decrease. However, in the late 1990s, revolutionary observations of distant supernovae revealed an astonishing result that left the scientific community baffled. The universe is not only expanding, its expansion is accelerating. Imagine a car that, instead of slowing down when you lift your foot off the accelerator, starts to speed up more and more. That is the surprising reality revealed by the data. Something invisible, something permeating all of space, is pushing galaxies farther and farther apart at an ever-increasing rate. This mysterious force was named dark energy. It represents roughly 70% of the total energy density of the universe, a staggering fraction that dwarfs ordinary matter and dark matter. But what exactly is this dark energy? This is where the connection to the quantum vacuum becomes profoundly intriguing. One leading hypothesis is that dark energy is nothing more than the energy of the vacuum itself. If the vacuum is not nothing but a fertile ground of virtual particles appearing and disappearing, generating intrinsic pressure, could this pressure be the force driving the accelerated expansion of the cosmos? Think of it. The quantum fluctuations of the vacuum, the incessant bubbling of particle-antiparticle creation and annihilation, give space an intrinsic energy density. This energy does not dilute as the universe expands. In fact, it remains constant per unit of volume. As space stretches, more vacuum is created, and with it, more of this inherent energy. It is as if the universe were a balloon inflating. As the surface area increases, the vacuum energy multiplies to cover the new area, maintaining a constant density. This property makes vacuum energy a perfect candidate for dark energy, unlike matter or radiation, whose density decreases as the universe expands. Vacuum energy has negative pressure, meaning that instead of attracting, it repels. It is intrinsic anti-gravity of space itself. This phantom pressure arising from the quantum depths of the vacuum is the engine driving the accelerated expansion we observe today. The challenge, however, is immense. While this idea is elegant, theoretical predictions of vacuum energy density are unimaginably large, trillions of times greater than the measured dark energy. This discrepancy is one of modern physics's greatest headaches, known as the cosmological constant problem. It is as if our theory tells us that the ocean of the vacuum should be boiling with unimaginable energy, yet what we observe is barely a gentle ripple. Despite this enigma, the connection between the quantum vacuum and dark energy remains one of the most promising paths to understanding the universe's future. If dark energy is indeed vacuum energy, it means the destiny of the cosmos is intrinsically linked to the nature of nothingness itself. It implies that the universe will never stop expanding. In fact, it will expand at an ever-increasing rate until galaxies drift so far apart that the universe becomes cold, dark, and empty, a scenario known as the Big Freeze or heat death. But even in that distant future, in the stillness of a vast and frozen universe, the quantum vacuum will continue to exist with its ceaseless bubbling of virtual particles. Dark energy, as an eternal and omnipresent presence, will continue driving expansion, a reminder that nothingness is never truly empty. It is a force that transcends matter and radiation, a fundamental manifestation of the potential inherent to space-time. Dark energy is not just an abstract concept. It is a window into the true nature of reality, a reminder that the universe's greatest mysteries are often found where we least expect them. It forces us to consider that the vacuum is not only the origin of creation, but also the architect of cosmic destiny. We have explored how the quantum vacuum is a vibrant sea of energy, the possible origin of our universe, and the invisible engine of its expansion. Now let us turn our gaze to the most enigmatic and extreme objects in the cosmos, those that challenge our understanding of space and time. Black holes. Could these cosmic singularities be more than mere gravitational sinks? There is a profound connection between them and the nature of the vacuum. Could they function as portals to other realities or as points where the vacuum reveals its deepest secrets? Imagine the death of a massive star. After exhausting its nuclear fuel, its core collapses under its own gravity, compressing into a point of infinite density, a singularity where known laws of physics break down. Around this singularity forms the event horizon, a boundary from which not even light can escape. This is a black hole, a cosmic abyss that warps space and time so extremely that anything crossing its threshold is doomed to disappear. Yet even near a black hole, the quantum vacuum continues to manifest. In fact, the interaction between the vacuum and the extreme gravity of a black hole led to one of modern physics' most revolutionary predictions, Hawking radiation. In 1974, Stephen Hawking proposed that black holes are not entirely black, but emit a faint thermal radiation as if they had a temperature. This radiation originates in the vacuum just outside the event horizon. How is this possible? Recall that the vacuum is filled with virtual particle pairs constantly appearing and disappearing. Near the event horizon, gravity is so intense that it can separate these pairs before they annihilate. One particle falls into the black hole while its companion escapes into space. This escaping particle is observed as Hawking radiation, energy effectively stolen from the black hole, causing it to slowly lose mass and eventually evaporate. This phenomenon is astonishing proof that the quantum vacuum not only exists but interacts deeply with gravity at extreme scales. It shows us that even in the universe's harshest conditions, vacuum activity is relentless and its effects are tangible. Black holes, far from being mere devourers, become quantum windows where the dance between gravity and the vacuum produces phenomena that defy intuition. The implication is profound. Black holes are not holes in the sense of absolute emptiness, but regions where vacuum energy density is affected in extreme ways. They could be considered points where the vacuum reaches its maximum information density or where the fabric of space-time is compressed to its quantum limit. Some theorists even speculate that black holes could be gateways to other universes or regions of space-time, not as physical travel, but as points of connection for vacuum fluctuations on an immense scale. Consider the possibility that matter falling into a black hole is fundamentally transformed into a reconfiguration of vacuum energy within. This opens the door to the idea that information is not lost, but encoded in the quantum properties of the event horizon or the vacuum itself, a central notion in the enigmatic black hole information paradox. Moreover, the existence of Hawking radiation and the way the vacuum interacts with black hole gravity lead us to question the vacuum in its most fundamental state. It may possess even more complex properties. If the vacuum is the matrix of everything and black holes represent matter's ultimate collapse, these extreme phenomena could be where the vacuum reveals its true nature as the primordial foundation of reality. Black holes, by their very existence and interaction with the quantum vacuum, force us to expand the limits of our imagination and science. They are the most powerful reminder that the universe is far stranger and more wonderful than our everyday perception allows. In their dance with the vacuum lie the secrets of creation and destruction, showing that even what seems a point of no return is a place of intense quantum activity, a portal to a deeper understanding of existence. Chapter 7. The Vacuum and Entropy. Disorder as the engine of existence. We have navigated the depths of the quantum vacuum, revealing its vibrant nature and its influence on extreme phenomena like black holes. Now, I propose an even more fundamental connection. One that unites the apparent chaos of the vacuum with the universe's universal tendency toward disorder. Entropy. How can the ceaseless bubbling of nothingness not only contribute to the universe's disorder, but also act as a crucial engine for its complexity and evolution? At the heart of physics lies the second law of thermodynamics, which states that the entropy of an isolated system always tends to increase. In simple terms, entropy measures disorder, or the number of ways energy and matter can be arranged in a system. Think of a new deck of cards, perfectly ordered. Shuffle it repeatedly, and the probability of returning to its original order is tiny. It will tend toward a state of greater disorder. Similarly, a drop of ink in a glass of water disperses until the liquid is evenly mixed, increasing the system's entropy. At first glance, the quantum vacuum, with its constant appearance and disappearance of virtual particles, seems the ultimate expression of entropy, a state of continuous, unpredictable fluctuations at infinitesimal scales. And in a sense, this is true. These fluctuations are inherently random and disordered. But here is where the paradox becomes fascinating. Vacuum energy, as an inexhaustible source of quantum fluctuations, actively contributes to the increase of entropy in the universe. Every particle-antiparticle pair that pops into existence and then annihilates represents a micro-event of disorder and reordering, a contribution to the ceaseless dance of information and energy. Fundamentally, the vacuum is like a boiling popcorn pot. Each individual pop is chaotic, but the collective process forms the basis of something much greater. Consider Hawking radiation. When a black hole emits virtual particles, it loses mass while simultaneously increasing the entropy of the surrounding universe. The information of what has fallen into the black hole is, in a sense, encoded in that radiation in the surrounding vacuum fluctuations. This is an example of how vacuum activity contributes to the diffusion of information and the overall increase of cosmic disorder. The entropy generated by the vacuum is a silent but powerful engine driving the universe's evolution. The constant quantum agitation ensures the universe never reaches a state of perfect stillness or absolute thermal equilibrium. There is always an energy flow, an intrinsic restlessness that prevents total stagnation. This fundamental unrest of the vacuum drives the arrow of time, the perception that time only moves forward. Think of the vacuum not as empty space, but as an engine of possibilities. Every fluctuation, every virtual particle, pair represents a possibility that is realized and then dissolved. An incessant exploration of possibilities. On a quantum level, this manifests on a macroscopic scale as the universe's inexorable trend toward higher entropy. And here comes the big idea. While entropy is often associated with decay and the universe's heat, death, it is also a fundamental engine for the creation of complexity. To form complex structures like stars, galaxies, and life, there must be a flow of energy and a direction in time. The universe's overall entropy increases, but within that vast system, temporary islands of order can arise. The underlying disorder of the vacuum, the constant flow of energy appearing and dissolving, provides the dynamic backdrop against which complexity can emerge, grow, and evolve. The connection between vacuum and entropy leads to a deeper, paradoxical vision of the universe. It shows that fundamental disorder is not an obstacle but a necessary condition for existence. Evolution, ultimately life itself, depends on the vacuum with its ceaseless bubbling of virtual particles. Not inert nothingness, but the heart of a constantly evolving cosmos. Here, chaos becomes the silent engine of creation, and complexity reminds us that even within apparent cosmic disorder, an underlying order allows the universe to follow its course, driven by the invisible heartbeat of nothingness itself. Universe as a hologram. We have journeyed through the depths of quantum vacuum energy and forces, understanding that it is not nothingness but an active engine of the universe. But now, prepare for one of the most revolutionary and mind-blowing ideas in modern physics. One that challenges our perception of what is real. What if the vacuum not only contained energy, but also information? Could the vast and complex reality we experience be a projection, an intricate hologram where every detail of the cosmos is encoded in the invisible fluctuations of this quantum sea since the universe began expanding? The amount of information it contains has grown exponentially. Think of every star, planet, molecule, and interaction. All of this is information encoded in matter and energy. But there is a fundamental place where all this information is stored or originates. Quantum physics points us once again to the vacuum. The idea that the universe is a hologram arises from attempts to reconcile gravity with quantum mechanics, especially in the context of black holes. As we have seen, black holes seem to devour information, conflicting with quantum laws that state information is never lost. To resolve this paradox, physicists like Gerard 't Hooft and Leonard Susskind proposed the holographic principle, The holographic principle suggests that the complete description of a volume of space can be encoded on a lower dimensional surface surrounding it. Imagine a three-dimensional hologram. All the information of a 3D object is imprinted on a 2D plate. Similarly, it is postulated that all the information describing our three-dimensional universe could be encoded on a kind of two-dimensional surface at the boundaries of the cosmos, or perhaps more fundamentally, in the fluctuations of the quantum vacuum itself. If true, this would mean that the virtual particles populating the vacuum are not merely bursts of energy. They are also carriers of information. Each appearance and disappearance of these particle pairs in the vacuum would not be a random, meaningless event, but a coding of the vast data that make up our universe. It's as if the vacuum were a screen of infinitesimal pixels flickering incessantly, and each flicker contributes to the overall image of reality. Consider the possibility that what we experience as solid objects, as three-dimensional space, and as the flow of time are projections of much more fundamental two-dimensional interactions occurring at the level of the vacuum. It's as if we are living inside a gigantic quantum simulation, and the source code of that simulation is inscribed on the surface of nothingness. This notion is profoundly counterintuitive because our daily experience tells us that reality is solid and three-dimensional. Yet quantum physics repeatedly shows us that the universe at its most fundamental level is far more malleable and astonishing than our intuition suggests. If the universe is a hologram, then the vacuum is the underlying matrix where all information is stored and processed. It is the digital canvas on which reality is painted. The implications of this idea are dizzying. If our reality is a projection, what does that mean for our existence? Are we ourselves part of this information encoded in the vacuum? It invites us to reconsider the nature of consciousness, matter and space-time. Could it be that consciousness itself is not merely a product of the brain, but a way in which this information from the vacuum is organized and experienced? The hypothesis of a holographic universe driven by the informational nature of the quantum vacuum opens a window to understanding a cosmos where nothingness is the universal library, the cosmic archive where every bit of existence is stored. It challenges us to look beyond the surface of what our eyes perceive and recognize that reality is an endless dance of energy and information, whose full script might be written in the invisible heart of the vacuum. Once contemplated, this idea has the power to profoundly transform your view of the universe. Chapter 9. Consciousness and the Vacuum. The mind as a cosmic mirror. We have unraveled the quantum vacuum as a vast ocean of energy and information, the possible architect of reality itself. Now I pose the most intimate and transcendent question of our journey. Is there an intrinsic connection between our own consciousness and the quantum vacuum? Could our mind be not just a product of the brain, but a cosmic mirror that interacts with, or even emerges from, the deepest fluctuations of nothingness? Consciousness has long been the ultimate enigma, that spark allowing us to experience, think, feel, and be aware of our own existence. Traditional science has largely considered it an emergent product of the brain's complexity, an intricate network of neurons and synapses. Yet quantum physics invites us to look beyond this materialistic view, suggesting that the substrate of reality is far subtler and more interconnected than we imagine. Quantum consciousness theories propose a deep interaction between the mind and the quantum world. If the vacuum is the foundation of reality, a field of potential and information, isn't it conceivable that human consciousness, at its most fundamental level, is somehow intertwined with this field? Some scientists and philosophers speculate that consciousness is not simply a neuronal epiphenomenon, but that its processes may involve quantum phenomena in the brain, such as superposition or entanglement. If these quantum processes are essential for consciousness, then by extension, our mind would be intrinsically connected to the same quantum vacuum from which these phenomena arise. It's as if the brain were an antenna tuned to the subtle vibrations of the energy information field that is the vacuum. Imagine consciousness as a sacred filter, a unique ability to collapse the infinite possibilities of the vacuum into the singular reality we experience. Remember, at the quantum level, particles exist in a state of superposition, multiple states at once, until observed. Could consciousness be the act of observation that somehow interacts with the vacuum to manifest a specific reality from the vast field of potentials? This resonates with ancient spiritual traditions speaking of a universal mind or cosmic consciousness, of which individual minds are mere facets. If the quantum vacuum is the reservoir of all energy and information in the universe, it could also be the substrate of a primordial form of consciousness. Our individual awareness would then be a reflection, a small wave in this vast ocean of cosmic consciousness expressed through the intricate neural networks of our brain. Consider that vacuum fluctuations are not mere random noise. They are the universe's fundamental language, the signals shaping matter and reality. If consciousness can tune into these signals, or even be one of them, then our mind may have a far deeper connection to the cosmos than conventional science has suggested. This does not mean that consciousness creates reality from nothing, but that it actively participates in its manifestation and perception. The implication is profound. If there is a connection between consciousness and the vacuum, then our mind is not isolated from the universe. We are an integral part of its fabric, and our subjective experiences could resonate on a quantum level with the cosmos itself. This invites us to see our own mind as a microcosm of the universe, capable of reflecting the complexity, potential, and mystery of the vacuum. Quantum consciousness is an invitation to an inner journey as vast and mysterious as the journey we have undertaken through the outer cosmos. We have traveled to the edges of awe, exploring the energetic and informational nature of the quantum vacuum and even its possible connection to our own consciousness. Now prepare for one of the most expansive and liberating ideas emerging from this deep understanding. The vacuum is not just a sea of energy or a repository of information. It is a field of unlimited potential, a place where everything possible exists simultaneously until brought into manifestation in our everyday experience. Reality appears fixed, with a linear past, present, and future. We believe things are or are not, but at the quantum level, this certainty disappears. Particles do not exist in a defined state until observed or measured. Before that moment, they exist in a superposition of multiple possible states. Think of a die spinning in the air until it lands and reveals a face. All faces are equally possible. The vacuum is that die spinning infinitely. This concept extends to the vacuum itself. If the vacuum is filled with quantum fluctuations of virtual particles appearing and disappearing, it is in a constant state of potentiality. It is not a blank canvas waiting to be painted, but a canvas that already contains all paintings, all combinations of colors and forms waiting to be selected. It is a vibrant field where all imaginable realities coexist as probabilities. Imagine that the universe is not a book already written, but an infinite library of books yet to be written. The quantum vacuum would be that complete library, containing the plot of every story, the potential outcome of every adventure, the birth of every star, and the collapse of every galaxy. Every event in our universe, every choice we make, every thought we have, could be a way of collapsing one of those infinite possibilities of the vacuum into tangible reality. This does not mean that our mind creates reality from nothing. As we saw in the previous chapter, consciousness could act as a focal point, a mechanism through which the vacuum's limitless potential materializes into experience. It's as if the vacuum offers a vast menu of possibilities, and our interaction, through scientific observation or conscious experience, selects a specific option. The implication that the vacuum is a field of unlimited potential is astonishing. It means that at a fundamental level, existence is not a series of fixed facts, but a constant flow of possibilities being updated. It is the true meaning of all and nothing. The vacuum, in its apparent lack of anything tangible, holds the totality of what can be. This perspective takes us beyond the materialistic understanding of existence. If the universe constantly emerges from a potential field, then creativity is not only a human trait, but an inherent cosmic force. The universe itself is in a state of continuous creation, driven by the infinite possibilities residing in the heart of the quantum vacuum. Every moment is a new birth, a new update of potential. Think of how this changes our view of miracles or improbable events. If the vacuum contains all possibilities, then what we consider impossible in our current reality might simply be a possibility with an extremely low probability of manifesting, but not non-existent in the field of vacuum potential. Ultimately, if the vacuum is the universal potential itself, then we are part of that immense network of possibilities. Our very being is connected to this limitless field, empowering us to see that our reality is not a fixed prison, but an ever-evolving canvas whose palette is infinite and resides in the very essence of nothingness. The vacuum is not only the origin of our universe, but also the inexhaustible wellspring of its continual evolution, of the infinite realities yet to manifest. Chapter 11. The Future of the Quantum Vacuum. Technologies beyond imagination. We have navigated the astonishing realm of the quantum vacuum, unraveling its secrets as a sea of energy, a field of information, and a well of unlimited potential. Now let me take you to the frontier of possibility, speculating about the future that awaits us if we master the understanding and perhaps manipulation of this powerful nothingness. What revolutionary technologies could arise beyond the confines of our current imagination? Consider the progress of science. Every great discovery, from electricity to atomic energy, has opened doors to countless innovations that once seemed pure fantasy. Understanding the quantum vacuum is emerging as the next great leap, a revolution that could redefine civilization and our relationship with the universe. One of the most fascinating and bold applications would be harnessing unlimited energy. If the vacuum is, as we have explored, a vast ocean of energy constantly manifesting in virtual particles, then theoretically, there is an inexhaustible source beneath our feet, permeating every cubic centimeter of space. Imagine a device capable of efficiently harvesting even a fraction of this energy, converting the vacuum's bubbling into electricity. It could permanently solve the global energy crisis, eliminating the need for fossil fuels or even nuclear power, ushering in an era of unprecedented energy abundance. Beyond energy, mastery of the quantum vacuum could revolutionize space travel. Vacuum fluctuations and their interaction with space-time are the key to concepts like exotic matter with negative pressure, which could theoretically be used to create warp drives. Such technologies would allow us to distort space-time around a ship, drastically shortening distances and enabling interstellar travel within human time frames. We would not travel through space, but fold space itself, powered by the energy of nothingness. Quantum computing could also reach its full potential. If the vacuum is a vast storehouse of information, and if consciousness can interact with it, could future technologies allow us to access or even process this information in ways that today seem like science fiction? We could be talking about computers not based on binary bits, but on qubits extracted directly from the properties of the vacuum, opening the door to unimaginable processing power capable of solving problems now deemed unsolvable. Quantum teleportation, already demonstrated on a small scale, could advance exponentially if we better understand how information entangles through the vacuum. If we can manipulate the underlying connections provided by the vacuum, the ability to transmit information, or even objects, instantly across vast distances could become reality. we would break the barriers of space as we know them. If the vacuum is the potential field where all possibilities exist, could advanced manipulation of this field lead to engineering reality itself at a fundamental level? This is the realm of the boldest speculation. If the reality we experience is a manifestation of information in the vacuum, we may one day learn to influence that manifestation at a quantum level, to develop new materials with properties impossible today, or even influence biological phenomena in ways we cannot yet conceive. These are glimpses of a distant future filled with colossal scientific and ethical challenges. Yet history teaches us that what is beyond imagination today may become the foundation of our reality tomorrow. The quantum vacuum, once considered the essence of absence, reveals itself as the key to unlocking an era of technological wonders. It is a testament that the greatest discoveries often hide in what we least understand, and that nothingness could paradoxically be the source of all our future progress. Chapter 12. Duality, the vacuum particle, an eternal dance. We have dazzled our imagination with the future possibilities of the quantum vacuum. Now we return to its most enigmatic foundations, to a property underlying all manifested reality. Even in nothingness, wave-particle duality. How does this eternal dance between diffuse waves and discrete particles influence the formation of matter and the laws governing our universe, even from the depths of the vacuum itself? At our macroscopic scale, we clearly distinguish between a wave, like ocean waves or sound waves, and a particle, like a ball or a grain of sand. Yet, at the scale of the infinitely small, this distinction fades. Fundamental entities such as electrons, photons, and even the vacuum's own virtual particles are neither one nor the other exclusively. They exhibit an astonishing duality. They can behave as waves or particles depending on how we observe them or how they interact with their environment. Imagine a photon, a particle of light. If we pass it through a double slit, it behaves like a wave, creating an interference pattern on a screen, as if overlapping waves. But if we try to detect which slit it passes through, it behaves as a discrete particle, choosing only one path. This paradoxical behavior is the heart of quantum mechanics and extends to the quantum vacuum itself. The vacuum fluctuations we described, the incessant bubbling of energy, can be seen as both a sea of vibrating energy waves and the ephemeral appearance of discrete virtual particles. It is a cosmic ballet where energy is not confined to a single form. It fluidly transforms between diffuse extension and point-like manifestation. This duality is crucial because it shows that the vacuum is not static. It is a dynamic field, a vibrant canvas where the rules of existence are rewritten at every instant. The energy waves of the vacuum ultimately give rise to the materialization of particles when the vacuum's energy collapses or condenses at a point. When that particle dissolves back into the vacuum, it returns to its wave-like state. Think of it as an ocean. Waves can concentrate and break, forming individual droplets, particles, that then dissolve back into the water body. The vacuum is that primordial ocean, and particles are its ephemeral droplets. Wave-particle duality in the vacuum means that matter and energy in our universe are not separate, immutable entities, but transient manifestations of an underlying field in constant flux. This perspective has profound implications for our understanding of the universe. It suggests that the space-time we perceive as three-dimensional and continuous could emerge from the interactions and vibrations of a more fundamental field. The vacuum, in its duality, is the substrate from which forces and ultimately all cosmic structures emerge. It is the primordial fabric, where the distinction between the physical and the ethereal blurs. The constant interaction and transformation between wave and particle states in the vacuum keeps the universe in a state of creation and destruction, the pulse that gives rhythm to existence. ensuring reality is always dynamic, ever-changing, and full of potential. Wave-particle duality in the vacuum is not merely a quantum curiosity. It is the revelation that nothingness is the arena where the most fundamental dance of the cosmos takes place. Eternal dance shaping all that is and all that could be. Chapter 13. The vacuum is the foundation of reality. Beyond matter. We have crossed veils of mystery, from quantum vacuum fluctuations to its dance with consciousness and particle duality. Now, I invite you to take an even bolder leap to the question underlying all others. What if the vacuum is not merely empty space, not just a sea of energy, but the ontological foundation of reality itself? What if this apparent nothingness is the primordial substance from which everything emerges, challenging our ingrained materialistic vision of the universe? For centuries, humanity has sought the fundamental substance of which the universe is made. The prevailing answer has been matter. We believe the universe is composed of solid, tangible building blocks, atoms, molecules, galaxies. Even the space between them was considered merely the place where these things reside. But as we have seen, quantum physics has dissolved this simplistic picture. If the quantum vacuum is a ceaseless field of activity of virtual particles that appear and disappear from latent energy that can manifest as matter or radiation, then nothingness is not inert. It is the active matrix of existence. It is the canvas, the artist, and, in a sense, the painting itself, all in one. This leads us to the profound idea that the vacuum could be the most fundamental basis of reality, the true substance from which everything else is a manifestation. Imagine that matter, energy, even the space and time we perceive, are like emergent patterns that form within the vast and complex web of the vacuum. It's as if the vacuum were a vast ocean, and what we call matter were the waves, the foam, the whirlpools that form transiently on its surface. The waves are real, the foam is visible, but their essence is the underlying ocean. In the same way, the material universe would be a densified manifestation, a condensation of the inherent fluctuations of the vacuum. This perspective echoes ancient Eastern philosophical traditions that spoke of emptiness as the source of all manifestation, not as an absence, but as a fullness of potential. Modern science, through the study of the quantum vacuum, seems to be rediscovering and giving empirical foundation to these millennia-old intuitions. The vacuum is not what it is not, it is what potentially is everything. Consider that the fundamental properties of particles, their mass, charge, spin, may not be inherent properties of the particle itself in isolation, but attributes that emerge in interaction with quantum vacuum fields, such as the Higgs field that grants particles their mass. The vacuum is not merely the space in which particles move. It is an intrinsic part of their identity and how they interact. If the vacuum is the foundation, then reality is not a collection of things, but a dynamic flow and constant interaction with an underlying field. Every atom in your body, every ray of light that reaches you, is not simply existing in the vacuum. It is in perpetual dialogue with it, emerging and returning to its primordial source at every moment. This radically changes our view of existence. We are no longer islands of matter in an empty universe. We are manifestations of points of consciousness and energy within a vast and omnipresent fundamental field. We are connected not only to the universe, but to the very essence of reality, revealing that we are intrinsically intertwined with the origin of everything. The idea that the vacuum is the foundation of reality invites profound humility and renewed awe. It shows us that nothingness is, in truth, the beating heart of existence, a place where the distinction between being and non-being dissolves, revealing a cosmos infinitely more mysterious, interconnected, and full of potential than we ever dared to imagine. Chapter 14. Quantum fluctuations, the invisible pulse of the universe. We have explored the idea that the quantum vacuum is the very foundation of reality, the primordial substrate from which everything emerges. Now, it's time to delve into the central mechanism driving this astonishing activity. Quantum fluctuations are the invisible pulse of the universe, the tiny yet omnipresent seeds that shape the creation and evolution of the cosmos. Imagine the space around us, even the space that seems most inert and empty. Our intuition tells us there is nothing there. But quantum mechanics reveals a much deeper dynamic truth at a subatomic scale. The vacuum is never at absolute rest. It exists in a state of perpetual agitation, an unending dance of energy. These are the quantum fluctuations of the vacuum. Remember Heisenberg's uncertainty principle, which dictates that we cannot know with absolute precision certain complementary properties of particles. This uncertainty is not a limitation of our instruments, but an inherent property of the universe itself. In terms of energy and time, this means that energy can fluctuate in the vacuum over extremely brief intervals. How does this manifest? It manifests as the spontaneous, transient appearance of virtual particle-antiparticle pairs. An electron and a positron, for example, may arise from nothing, exist for a fraction of a second. So minuscule it defies imagination, perhaps a billionth of a second, and then annihilate each other, returning energy to the vacuum field from which they emerged. It's as if the vacuum is constantly blinking with these fleeting births and deaths. Think of the vacuum as a vast, turbulent sea. Quantum fluctuations are the waves and whirlpools forming and dissolving on its surface every instant. Although individually ephemeral and impossible to observe directly, their collective effect is immense and measurable. As we have seen with the Casimir effect, the pressure exerted by these virtual waves produces the attractive force between metallic plates. But the impact of these fluctuations goes far beyond. They are crucial to the stability of atoms. The clouds of virtual particles surrounding electrons, for instance, modify their energy and interactions with the atomic nucleus. Without these fluctuations, the structure of atoms would be different, and chemistry, as we know it, would not exist in a very real sense. The pulse of the vacuum is what allows matter to exist and organize. Furthermore, quantum vacuum fluctuations are considered the primordial seeds from which galaxies and the large-scale structures of the universe formed in the earliest moments of the Big Bang. During the phase of cosmic inflation, when the universe expanded exponentially, these tiny quantum fluctuations were stretched to cosmological scales. These minute inhomogeneities in energy density became the gravitational seeds that, over time, attracted matter and formed galaxies, galaxy clusters, in the vast cosmic web we observe today. The universe, on its largest scale, is a gigantic echo of the tiny fluctuations of the vacuum in its origins. Quantum fluctuations are not just a technical concept, they are a profound revelation of the dynamic nature of reality. They show us that the universe is not a static place where things simply exist, but a field of constant creation, an unceasing surge of energy that manifests and dissolves, giving rise to matter. The forces and structures we know are the invisible heartbeat of the universe, a constant reminder that nothingness is, in truth, teeming with potential and activity. This understanding compels us to see the cosmos not as a static machine, but as a living organism, always in flux, constantly creating and recreating itself from its deepest foundations. Quantum fluctuations are the breath of the universe, the most elemental manifestation of its inexhaustible vitality, ensuring that existence is never dull and always full of wonder. Chapter 15. The Vacuum and Quantum Teleportation, Breaking the Barriers of Space. We have understood that quantum fluctuations are the vital heartbeat of the universe, the seeds of all creation. Now, let's explore one of the most astonishing consequences of quantum physics, a phenomenon that seems like science fiction but is experimentally proven: quantum teleportation. How can the quantum vacuum influence this marvel, breaking the barriers of space and opening the door to a cosmic connectivity that defies our most deeply held logic? When we think of teleportation, our minds often conjure images from TV shows where people or objects dematerialize in one location and instantly reappear in another. Quantum teleportation is not exactly that. It is not about physically moving matter from one place to another, but about transmitting the quantum state of a particle from one point to another without the particle itself traveling. It's as if we send the complete blueprint of a particle to another location, where a new particle is created with the same properties, replicating it exactly. At the heart of quantum teleportation is quantum entanglement, a phenomenon we will explore in more detail in the next chapter, but it is crucial to understand the role of the quantum vacuum. Remember, the vacuum is not empty. It is filled with virtual particles and an immense network of quantum fields interconnecting the entire universe. It is like a vast, invisible sea of information, and teleportation is one way we can surf its waves. Imagine you want to teleport the state of a photon. You cannot simply scan and reconstruct it because the act of measurement would destroy its delicate quantum state. This is where the magic of entanglement comes into play. Two auxiliary particles, A and B, are entangled so that their states are intrinsically linked, no matter how far apart they are. If you then interact the particle you want to teleport, P, with particle A, the information about P's state is instantaneously encoded in particle B, even if it is kilometers away. Particle B assumes P's state, and the vacuum acts as the medium through which these entangled connections exist and persist. The quantum vacuum is the underlying fabric that allows quantum information to be transmitted and remain coherent despite distance. Its fluctuations, far from being noise, are the silent language that enables instant communication between entangled particles. Think of the vacuum as a gigantic cosmic neural network, a kind of quantum internet. Entangled particles are nodes in that network, connected through the underlying field. Quantum teleportation is the manifestation of how information can leap from one node to another, using the vacuum as the invisible conduit. This ability to transmit quantum states across space has revolutionary implications. It is currently used for secure quantum communication, where information cannot be intercepted without being destroyed, laying the groundwork for a long-term unbreakable quantum internet. Understanding how the vacuum facilitates these connections could lead to unimaginable advances, perhaps even helping us understand how information is organized on the larger scales of the universe. Quantum teleportation is a striking reminder that space, as we perceive it, is far more flexible and malleable than we thought. Nothingness is not an obstacle to connection, but the catalyst for the deepest and most mysterious connections in the universe. It shows that barriers we once believed insurmountable may, in reality, be illusions, and that the quantum vacuum is the key to unraveling a cosmos where information flows freely, breaking the limits of what we thought was possible. It is a window into a universe where connectivity is fundamental, and what once seemed like science fiction is a remarkable manifestation of the laws of reality. Chapter 16. The Vacuum and Quantum Entanglement. The Invisible Cosmic Connection. We have glimpsed how the quantum vacuum enables wonders like teleportation, acting as a medium for information transmission. Now, let us delve into the heart of this miracle. Quantum entanglement could be the vacuum, with its incessant bubbling of energy and vast field of information, the underlying fabric that allows this instantaneous connection between particles, revealing a fundamental unity throughout the universe that goes beyond everyday understanding. Imagine two coins. If you flip one and it lands heads, the other can land heads or tails independently. There is no connection between them. But in the quantum realm, things are radically different. Quantum entanglement is a phenomenon where two or more particles form or interact such that their destinies are intrinsically linked regardless of the distance separating them. If you measure a property of one, you instantly know the property of the other, even if they are light years apart. Albert Einstein, perplexed by this, called it spooky action at a distance. How is this possible? No signal travels from one particle to the other. There is no invisible wire or communication traversing space. The connection is instantaneous, defying the speed of light and our classical intuition. Here is where the quantum vacuum comes into play, not as mere empty space, but as the fundamental mediator of this astonishing relationship. Think of the vacuum as a vast ocean of potential and invisible connections. When two particles become entangled, it is not that a new connection is created. Rather, their states synchronize in a way that resonates with the fundamental structure of this quantum ocean. The vacuum is like an omnipresent cosmic neural network, and entangled particles are nodes in that network that activate simultaneously. They do not need to send signals because they are already part of an underlying unity that connects them through the depths of the vacuum. The quantum fluctuations of the vacuum, the incessant dance of energy and virtual particles, are not mere noise. They are the medium through which information flows. At this fundamental level, the entangled connection is recorded in the substrate. When we measure an entangled particle, we are, in a sense, interacting with a localized manifestation of information that already exists in the vacuum field. This interaction instantly defines the state of its distant partner through that pre-existing connection in the fabric of the cosmos. Consider the profound implication. If the vacuum is the matrix that allows entanglement, then the entire universe could be fundamentally entangled. Every particle, every atom, every galaxy could be connected at a level beyond what we can see or touch. Our perception of things as separate and discrete would be an illusion at the macroscopic scale. At the level of the vacuum, everything is unified. Everything is part of an interconnected cosmic network. This vision leads us to reevaluate our own existence. If we are collections of particles, and those particles can be entangled with others across the universe through the vacuum, what does that mean for our individuality? In a deep sense, we might be localized manifestations of a vast unified quantum field, and our minds, as we explored in Chapter 9, could be attuned to that cosmic resonance. Quantum entanglement, facilitated and sustained by the vacuum, is one of the most powerful pieces of evidence that reality is far stranger and more wondrous than our senses tell us. It shows us that connections do not always require a distance to traverse or a visible physical medium. The deepest connections in the universe are invisible, ethereal, and reside at the heart of nothingness itself. The vacuum is not just the backdrop of existence, but the warp and weft weaving the immense network of relationships that make up our universe, revealing a fundamental unity that invites constant awe. Chapter 17. The temperature of the vacuum. A cosmic cold full of life. We have navigated the mysteries of the quantum vacuum, understanding its role in entanglement and cosmic connectivity. Now, let us explore one of its most paradoxical properties. Despite its apparent coldness and emptiness, the quantum vacuum possesses an intrinsic temperature. What implications does this cosmic cold have for the stability of the universe? Surprisingly, it may even influence the possibility of life in the most inhospitable corners of space. When we think of the vacuum of space, we imagine extreme cold near absolute zero, where matter and energy are scarce. And largely, this is true for interstellar and intergalactic space. However, at a more fundamental level, the quantum vacuum is not a place of thermal stillness. It exists, as we have seen, in a state of constant ebullition, a boiling cauldron of virtual particles appearing and disappearing. This inherently energetic activity gives it a form of temperature. The idea of a vacuum temperature arises from several perspectives in quantum field theory. One of the most famous is the Unruh effect, which predicts that an observer accelerating through the vacuum will perceive a thermal bath of particles as if the vacuum itself were hot. This is a profoundly strange concept because for an inertial observer, one who is not accelerating, the vacuum would appear cold. The vacuum reminds us that even the very definition of particle and vacuum depends on the observer's state of motion. The quantum vacuum itself has a background temperature related to its inherent fluctuations. While it is not a temperature we can measure with an ordinary thermometer, its effects manifest in how quantum fields interact and in the energy the vacuum can harbor. This vacuum energy is what some propose as dark energy, the phantom pressure that drives the universe's accelerated expansion. Consider the cosmic microwave background, CMB, the fossil radiation of the Big Bang. The remnant heat of the early universe today has a temperature of approximately 2.7 Kelvin, almost minus 270 degrees Celsius, an icy chill. Yet even in this extreme cold, the vacuum still harbors its own intrinsic energy, which does not cool in the same way as matter or radiation. The implication that the vacuum possesses a temperature, however subtle, is crucial for the universe's stability. If the vacuum were truly nothing in the absolute sense, devoid of any energy or fluctuations, the universe could not exist as we know it. The inherent temperature of the vacuum is a manifestation of its zero-point energy, the minimum energy that a quantum system cannot lose even in its ground state. It is like the constant hum of a motor that never shuts off. Even when the car is stationary, this energy is not an anomaly but an integral part of the physics of the universe. This intrinsic vitality of the vacuum contributes to the conditions that allow the formation of stars and galaxies and, ultimately, life. Paradoxically, the apparent cold and stillness of cosmic vacuum is full of latent energy that underlies all existence. Consider the delicate balance that allows the universe to be habitable. If the vacuum energy was slightly different, or its intrinsic temperature not finely tuned, the universe might have collapsed or expanded too quickly for structures to form. The existence of this vacuum temperature indicates that nothingness is not a dead space, but a living, finely tuned entity that sustains the structure and evolution of the cosmos. Even in the coldest and seemingly emptiest reaches of space, the universe remains a place of astonishing quantum activity. The temperature of the vacuum is not merely a theoretical curiosity. It is a window into the hidden vitality of nothingness. A reminder that even in the deepest cold, there is fundamental energy that permeates and shapes all existence, opening the possibility that life in its subtlest forms may be connected to this cosmic cold. We have explored the astonishing inherent temperature of the quantum vacuum, revealing its hidden vitality. Now I invite you to expand your conception of reality even further, venturing into one of the most fascinating and speculative ideas in theoretical physics. What if the vacuum not only concealed energy and information, but also additional spatial dimensions beyond the three we perceive? Could the quantum vacuum be the gateway to a vast, multi-dimensional universe, where the laws of physics are even stranger and more fascinating? Our everyday experience unfolds in three-dimensional space: up, down, left, right, forward, backward. Add time, and we have four-dimensional space-time. For decades, physicists have speculated about additional compactified dimensions, curled up at scales so tiny that we cannot detect them with our senses or current technology. The idea of extra dimensions arises from theories such as string theory and M theory, which attempt to unify all the forces of nature, including gravity and quantum mechanics. For these theories to work mathematically, the universe often needs more than 4 space-time dimensions, perhaps 10, 11, or even more. But if they exist, where are they? And crucially, how does this relate to the quantum vacuum? Here, the connection becomes profound. The quantum vacuum might not be just the space we know, but the place where these hidden dimensions reside. Imagine that each point in our three-dimensional space is actually a tiny universe, with additional dimensions so small that they are invisible to our eyes. The vacuum would be the manifestation of these compactified dimensions, teeming with the vibrations and fluctuations of these extra realities. Think of a garden hose viewed from a distance. It appears one-dimensional, but up close, you see that it has a curled dimension around its circumference. Similarly, these extra dimensions are thought to be tightly curled, possibly in complex shapes called Calabi-Yau manifolds, or that the objects and forces we know are confined to our flat, three-dimensional reality. But the virtual particles of the quantum vacuum, being inherently quantum and existing at infinitesimal scales, might not be confined to our three spatial dimensions. They could be exploring these hidden dimensions, appearing and disappearing within them. It is as if the vacuum is the great cosmic explorer, the only one with access to every nook and fold of multi-dimensional reality. This interaction of the vacuum with hidden dimensions could have massive implications. It might explain why gravity is so weak compared to other forces like electromagnetism. If gravity can leak or propagate through these extra dimensions while other forces remain confined to our three-dimensional universe, its effect in our reality would be diluted. Vacuum energy in this context would not only be the source of the particles we know, but also of interactions extending across these hidden dimensions. Consider the possibility that what we perceive as vacuum energy, or even dark energy, could be a manifestation of energy residing in these hidden dimensions, subtly projecting into our reality. The existence of hidden dimensions mediated by the quantum vacuum invites us to a vision of the cosmos where nothingness is far more complex and rich than we ever imagined. It shows that the universe is a far larger and layered place than our senses reveal. A place where the boundaries of reality blur and the vacuum is the key to unlocking a truly multi-dimensional understanding of existence. This perspective leads us to consider a profound idea that resonates with humanity's deepest intuitions. Could the quantum vacuum be the substrate of a collective consciousness, a universal network of information connecting not just minds, but all existence? We may ultimately be part of a larger cosmic mind, reflecting intelligence inherent in the vacuum itself. The idea of a collective consciousness is not new. Philosophers, mystics, and thinkers throughout history have postulated the existence of a universal mind, a world soul, or a field of consciousness of which all individual minds are mere expressions. What is new is how quantum physics and the understanding of the vacuum may begin to provide a scientific framework to explore this notion. If the quantum vacuum is a sea of energy and information, and if this information can be fundamentally entangled across space and time, then the vacuum is not merely a passive container. It is an active, dynamic network, a sort of cosmic nervous system connecting every point in the universe. Every fluctuation, every virtual particle appearing and disappearing could be a unit of information in a vast cosmic library. Imagine individual consciousness, not just yours or mine, as a manifestation or access point to this much larger information network. If the brain is an antenna tuned to the vacuum field, as suggested in earlier chapters, it might be receiving and processing information beyond mere neural signals. We could unknowingly resonate with a universal mind permeating the cosmos. Think of quantum entanglement. Two entangled particles share an instantaneous fate across the void that separates them. Isn't this a powerful metaphor for how minds, or even the fundamental elements of existence, could be interconnected through the vacuum? This connection would be invisible to our senses, but operational at a fundamental quantum level. Uniting everything in profound unity, this perspective invites us to consider that intelligence or information is not just a property of matter, organized as a brain, but an inherent quality of the universe itself, embedded in the structure of the vacuum. The universe, in this sense, may not be a blind machine, but a potentially conscious system, with the vacuum as the matrix of that consciousness, our very existence. This is a frontier where science meets philosophy. We are far from fully understanding the nature of consciousness, let alone proving its connection to the vacuum. Yet it is a fascinating avenue of exploration that challenges our most ingrained notions of separation and individuality. If this vision is even partially correct, it has profound implications for understanding ourselves. We are not isolated beings, but parts of a vast consciousness extending across the universe. Every experience, thought, and emotion may resonate within the cosmic fabric of the vacuum, contributing to a kind of universal mind. This invites us to live with greater interconnectedness, humility, and awe, recognizing that our own existence is an echo, or perhaps a facet, of the infinite intelligence inherent in the vacuum itself. We have reached the end of this extraordinary journey, a deep dive into the secrets of the quantum vacuum. That space, once seeming the very definition of nothingness, from the fluctuations that give it life to its role as the potential origin of the universe. Its influence on cosmic expansion and enigmatic phenomena, like black holes and quantum entanglement. We have revealed that the vacuum is not empty, but the vibrant heart and very foundation of all reality. We explored the Casimir effect, where nothing manifests as a measurable force, a tangible proof that space is not inert. We marveled at virtual particles, the ephemeral yet omnipresent pulse beating in every corner of the cosmos, the ballet of creation and annihilation shaping matter and energy. We explored how this vacuum may have been the primordial spark that ignited the universe, and how its intrinsic energy, dark energy, continues driving its accelerated expansion, dictating the fate of galaxies. We peered into the abyss of black holes, discovering that even at their boundaries, the quantum vacuum emits Hawking radiation, revealing a deep connection between extreme gravity and quantum nothingness. We saw how the vacuum and entropy intertwine, showing that apparent disorder at a fundamental level is paradoxically crucial for complexity and evolution. We then entered the realm of information, contemplating the universe as a cosmic hologram, where every facet of reality is encoded in the subtle vibrations of the vacuum. This led us to the intimate reflection on the connection between our consciousness and the vacuum, suggesting that our minds may be cosmic mirrors tuned to a universal mind permeating existence. We recognize the vacuum as a field of unlimited potential, the place where all possibilities coexist, waiting to be manifested. We speculated on future technologies arising from manipulating this field, from limitless energy to interstellar travel beyond imagination. Wave-particle duality revealed the eternal dance between form and formlessness at the heart of the vacuum. We understood that this is the ontological foundation of reality, the primordial substance from which everything emerges. We explored quantum fluctuations as the universe's invisible heartbeat, the tiny seeds that gave rise to galaxies. We marveled at quantum teleportation, a wonder that breaks spatial barriers through the vacuum network, and quantum entanglement, the invisible cosmic connection uniting everything in profound unity. Finally, the vacuum's inherent temperature revealed that even in the deepest cold, fundamental energy permeates existence. This could be the substrate of hidden dimensions, inviting us to a universe larger than we see. This journey has shown that the vacuum, once a symbol of absence, is revealed as the inexhaustible source of everything, the origin and destiny, the beginning and the end, where science and mysticism converge to unveil a reality infinitely deeper, interconnected, and more astonishing than we ever dared imagine. Your vision of the universe and of yourself will never be the same. Exploration does not end here. Every question we have asked is a doorway to a new universe of knowledge. If this journey has inspired you, if your mind has discovered new awe for the cosmos, continue exploring these wonders. Join the Quantum Observer community. Subscribe to the channel to continue unveiling the secrets of reality together, because the universe always has more to reveal, and the adventure of understanding never ends.